Hi everybody, welcome to the track number 6, class 1 of how we can use artificial intelligence techniques to container port logistic operations. My name is Anibal Azevedo, and now in this track we're gonna explain previously tracks and what and how we can use quay crane rules that we defined in previously track in this track. So if you didn't see the track number 5, it will appear as a car somewhere to the playlist. It's important to know something about the quay cranes operations, how to create rules to operate quay cranes, and also it's important to say how we can use it in a simulation, how we can adapt your previously simulation that we saw in a previously track, occurred for a previously track, will appear in a moment, and how we can adapt this simulation to use these quake cranes rules. So let's see what we have seen in previously tracks to know how what we should do in this track. So we are in the track number 6, as I said before, and all the codes, developed code will be available in the description of this video, okay? In a notebook, Google Club notebook. So let's see. The main objective of this sequence of tracks is how we can how we can apply artificial intelligence to help in supply chain logistics. So in the first track, a card for the first track will appear somewhere. We said how we can create a class that can model the container ship space. Okay, the space are divided in cells, and a group of cells can be formed per bay. So it's a very well structured space. So we defined this class container ship in the first track, and we are able also to see the container ship or to put cargo, unload or load cargo as we done in the second track. In the second track was very interesting because we defined unloading and loading rules. So the unloading and loading rules emerge when we have the container ship and we have to interact the container ship with the yard, with the port. So you have to put some cargo from yard to container ship, so you can use loading rules. Loading rules are just to define how we're gonna occupy the container ship space. Okay, and unloading rules we define how to remove containers from the container ship. There are several ways to do it. Okay, so now this is just a demonstration of how, depending on what kind of unloading or loading rule you apply, the configuration or the container ship arrangement, the containers that are arranged inside the container ship will be displaced in a different manner. So we manually code many kind of rules. So we also in the future tracks we're gonna see how we can avoid this. Okay. In the third track, we also see this how we can combine container ship and loading rules through ports. So we are the major concern here is how we can build a simulation of operation of ship through ports. So we can use it. This compact representation is very interesting because in each port we define an integer number, and this integer number is a combination of what rules we can use it in this port. We should use it in this port. The rules can be unloading or loading or quay crane operations rules or what else, whatever you have in the port. Okay, so what's interesting here is that after doing these operations, after applying these unloading and loading rules, for example, or more rules, you can get, for example, the total number of movements that you made through ports using this ship and using the rules. to loading or unload rules to, to put cargo or to remove cargo from ship. So what's important, you can change this as, for example, you can see how much time you're going to spend with this ship during this travel, along this travel. Okay, so we have a kind of chain of rules when we apply this rule through ports and using this ship. And what is most important here is that after we can see this simulation in this simplified way, and this simplified way give us just only the number of movements. Okay, so we extract the unloading and loading operations. We can extract how many movements we're gonna use by using certain kinds of rules. So in the fourth track, we saw the genetic algorithm because remember that we can have many combinations of rules. Here we can have, for example, 12 possible rules. We can increase the number of rules. So this can be a very large combinatorial problem. And how you can solve this combinatorial problem, or at least get a better quality solution instead of using a random solution, you can use it kind of genetic algorithm. Each line of this matrix, it's an individual. You can have many individuals in random individuals, and applying this scheme, this evolutionary scheme, you can get a better result, better than the initial random solution. So this is more detail um, about this scheme, how we can apply this, and also we have the decoding scheme detail here, and the necessary database of rules. Okay, loading, loading, and quay crane rules. We can also consider, and also extracting after doing a simulation. We can extract the number of movements or total time to perform the operations. So to compute the total time, it's important to consider the quay crane. So in the track number 5, we saw this, how we can consider quay crane rules to operate more than one quay crane, because quay cranes should keep a minimal distance between them. So it's important to consider this. And also you have to consider how much time they're gonna take to operate, or how much time they're gonna spend moving through between container between bays. So this is an interesting and important problem that we use it also. We applied also rules here, and in this track, let's talk about what we're gonna see in this track. In the track number 6, we're gonna see how we can connect the quay crane rules to your previous simulation. Remember that we saw in the track number 4, number 3, sorry, in the track number 3, we saw how we can simulate and extract the total number of movements. Okay, so now we can just put a little different computational issue here. We have to consider the base of the container ship, not the detailed container ship, but instead we have to transform this detailed container ship space into base. So you have to account how much workload we will have to do for each bay. So after doing this, you can use this information to compute the total time by applying the quay crane rules. So after doing this, you can get, for example, the total time necessary to perform all operations in a ship in a certain port, or for all ports of this that this ship will go. So that's it. A great overview of what we are doing, why we are doing, and what we are going to do to the next class. We are going to use some code, explain this code, the adaptation that we should make to consider quay crane rules in your simulation, and it will be a very high level code comments. We have comments in high level because it's more easy to understand just before you have a high level comprehension of the code. So instead of doing, okay, let's do it, all the code will be in the description of the video so you can explore, you can test, but I will give the basics to you to understand what's going on the code, okay? So that's it. Thank you for your attention. I hope you find this video interesting and useful, and see you in the next video. Bye.